Hello friends, we are bigdatahands-on.com.
Uh, uh, Irfan, have you started the recording?
Yeah.
Okay.
So today is day 24. We are going to see introduction to clustering and K-means clustering DBSCAN algorithm. So previously we have taken support vector, naive Bayes, random forest, mission tree. These are algorithms or machine learning we have seen. From day 15 to day 29 we'll see machine learning. Previously from day 4 to day 14 we have seen the Python.
Some other noise is also hearing, Irfan.
uh, from me or I think from me. Okay, wait.
Yes, I guess it's from you, I guess. Yeah, now you can proceed.
Okay, now okay. So we have seen from day 4 to day 14 we have seen the Python videos, and day 1 to day 3 we have seen the statistics and probability. These all videos will upload in our YouTube channel bigdatahands-on.com. If you subscribe to our channel you will get all the updates. Our website bigdatahands-on.com, so you can visit our website. If you have any doubts you can message us in this number 978928424, or you can send email through support@bigdatahands-on.com. Okay, so let me jump into today's topic. So today is the clustering algorithms. What is clustering actually? So clustering is an unsupervised learning. It comes under unsupervised learning. So in unsupervised learning, usually we don't have any labeled data. In supervised learning, we have seen some labeled data. That means for this uh, results, uh, the results already given for us, right? So in the training data, but in the unsupervised learning, we don't have any um labels. So we label them with the clusters, number of clusters we create. So number of clusters are created with similarity and dissimilarity, basis of the similarity and dissimilarity between them. So clustering is the task of dividing the population or data points into a number of groups such that data points in the same groups are more similar to other data points on the same group and dissimilar to the data points in the other groups. Okay, this is the clustering task, is that dividing the population. And now in the clustering we have many algorithms like K-means, DBSCAN, hierarchical, agglomerative, like we have. But K-means is the one of the most common algorithm in for clustering. So we'll see that first. K-means clustering is one of the most common unsupervised learning algorithms in data science. Okay, and K-means algorithm is an iterative algorithm that tries to partition the dataset into K predefined, distinct, non-overlapping subgroups. So that are clusters, where each data point belongs to only one group. So K predefined means we need to give the number of clusters. We define the number of clusters in uh, creating the model. When creating the model we give the number of clusters, and based on the number of clusters it's try to divide the it's try to create the clusters, non-overlapping subgroups, and where each data point belongs to only one group.
Irfan, some other noise is getting heard, Irfan. Like, all others are able to hear clearly, or is there any other external noise is getting composed, right?
Is it okay?
Yeah, just now it should be fine, Irfan. One person, no. Okay, there is no external noise, so you can proceed, Irfan.
Okay, okay. And now steps involved in K-means. So when creating the model, we specify the number of clusters. That's K here. So what we do basically, let's say I will draw that in here. Let's say we have the data points. This the axis X and Y. We have some data points in there. Let's take and now what we are going to do is, let's take number of clusters equal to 4. So then what happens is, the second step what it does is initialize centroids by first shuffling the data sets and then randomly selecting k data points for the centroids without replacement. For example, let's say this is the data points here right now, and now we are going to shuffle the data set and select three random, sorry, four. Uh, if number of clusters we are given 4, then it will select 4 points from the data points. Let's say I'm selecting this point. Oh, not this one. I'm going to select this point, and let's select this point, and here this point, and this point. So we have selected k data points from the for the centroids. So now these yellow rounded are the centroids for our clusters. Then what happens in the third step, compute the sum of the square difference distance between the data points and all centroids. So that means we calculate the distances between the centroid and the data points. For example, here to here, this centroid to this point, and this centroid to all other points, will calculate the distances. And what happens after calculating the distances, we'll assign the data point uh, to the nearest centroid. For example, let's take this point. So I need to assign the data points which cluster is near to this point. So this cluster is near to this point, so I will assign this point to that cluster, and this point also is belongs to this cluster, and these 2 points also belongs to this cluster, because these points are more far away from these points, right, from this cluster. So that's why we assign these 2 points. But what about this point? uh, this point is more closer to this cluster, but it's far away from this cluster, so we can remove that. We'll remove this and this. So this how the mean k-means clustering is working. In the first step, what I said before, the same thing is here. Assign each data point to the closest cluster, that's it. And 5, the step 5. So why we are saying k-means clustering is an iterative algorithm? Because of this step 5, keep iterating until there is no change to the centroids. We are randomly selecting the centroids. So the k-means clustering will iteratively try with randomly. So again it will select randomly centroids, and again it will compute this distance. Again it will assign the data points to the clusters. So until there is no change to the centroids. That's what in k-means clustering it does. Okay. So now this what is happening here. So the star is our cluster centroids, and these data points are assigning to the closest centroids, right? And this animation here, so you can see what happens in here. K-means iteration 1, 2, 3, and iteratively you can see it's just changing the position right here, right? So this is how the K-means clustering is working. So now let's try to implement the k-means clustering. So we have a doubt, like we will have uh, the doubt is where I need to use the clustering algorithms. Clustering algorithms we use when we want to divide the data set, or when you have a non-labeled data, or you can use for customer segmentation problems. We can use the clustering algorithms. So these are the use cases. And let me open the spider. And the data sets, you can find it in Kaggle website. Go to the Kaggle. For customer segmentation also is available in the Kaggle website. For example, if I say go to the data tab here and search it, customer segmentation, you will get, I think that's small customer segmentation. Segmentation. So here, so you need to uh, find the appropriate number of clusters for this data set. What? Okay. So the data set we have customer ID, gender, age, annual income, and spending score. So based on this, we need to divide the customers into number of clusters. Okay, based on the annual income or age, like that. Okay, so let me create a file here, new file, and then we'll save it. Okay, so let's name it as KMeans.py. Now first, let me import the libraries for like pandas, numpy, and matplotlib. Let me import that. Import pandas as pd. Import numpy as np, and matplotlib as well, to visualize the data set, to visualize the clusters created. And to style the plot, we'll import the seaborn library. The plots will look nice and seaborn, that's why. And now set the style as white grid. Set underscore style as white grid. Okay, now let's run this. So I will demonstrate you the clustering algorithm K-means with the dummy data, like in the sklearn data set we have. Let me import that sklearn.dataset. You can import the function which I'm going to use is that is not this one actually. That's inside pandas, I think. Yeah, pandas make underscore. Sorry, from I need to put. That's why it's not coming. Make blobs, and I will import make circles. Make blobs will create like clusters data only. It will create make blobs, and make circles will create a circle type of data. So first, let me create x and y, and we'll first call the make blobs function, and we'll give the number of samples here. Number of samples I will give 1500. Let's take a large data, 1500. And what we do is we can assign the random state also. If you want, you can give, otherwise leave it. And what and then first we'll visualize the data first, how the blobs is look like. So you can say plt.scatter, and you need to give the features as well, I think. Yeah, number of feature I will give 2. Okay, number of features equal to 2. So it will give 2 features in the x data. So you can plot the 2 features like this. So all the rows, and select the first column, that is 0 index. So this is the first feature, and the y-axis will be all the rows of x, and the column which is 1, that means the second column, the index is 1. So we are plotting these 2 features in the x, and the color will be the y, the labels, right? The y is the color now, and we'll show it plt dot show, right? That's it. Now let's run this. Now in the plots tab you can see the plots. Yeah, this is the data here. So this is the blobs. It's like a clusters only. So we'll try to divide the clusters using the k-means algorithm. So we create the clusters like this using the k-means. So these clusters is known from the labeled data y, but we are not going to use the use the attribute y. Okay, we are just going to use the x variable here, and then using the k-means algorithm we are going to create a clusters like this. Okay, the result needs to be like this. Okay, so for that, let me import the uh, k-means class first in the sklearn library. In the sklearn library we have a module called clustering here. Clustering module, cluster. In this cluster you will find all the clustering algorithms. So we want k-means, right? So you can see all our clustering algorithms. So first we'll import the k-means, and we need to create the object for that. So let's see, cluster equal to k-means cluster, and it takes some parameters. If you want to see, you can press Ctrl I. It will show the help in the help tab, show the attribute and what the attributes are. So you can see number of cluster, n cluster equal to, the default is 8. So the number of cluster to from, as well as the number of centroids to generate. Okay, and in it we have k-means plus plus random end array callable. So default is k-means plus plus. This for method for initialization. So initialization, I said before, in the second step what we do, we shuffle the data set and then we'll select the number of centroids, right? So it's what the step initialization is. And we have the default n init is 10, and max iter. So max iter means number of times which the k-means try to iterate and try to fit the clusters. Okay, so that is defaultly 300, maximum number of iteration for the k-means algorithm for a single run. Okay, and I think we don't want this. Distance, pre-compute distance, random state also we can assign. And what other we have, that's it. Okay, so first we'll give the n cluster here. clusters, right? uh, yes, equal to, I will give three clusters. Let's see what happens. Or okay, first we'll give three clusters, because it is two features, we can give two clusters as well. So let me try with three clusters how it's working, and then we'll see. Okay, now we have created the cluster, so we need to fit into the data, that is x here, not y. So we are not going to use the y variable, so we just give the x data, and then it will create the clusters. It will give you the cluster centroids, or you can say it will predict that. So you can say labels labels equal to cluster dot predict. The cluster dot predict will give you the number of clusters that are labeled like 0, 1, 2. In these labels you will see 0, 1, 2 values. If I run this, uh, so now if I labels here, sorry, labels, so you can see array of 0, 1 and 2. So 0 means the cluster number 1, 1 is the cluster number 2, 2 is the cluster number 3. Okay, I think you can visualize here. So for every data points we have cluster, we have assigned a cluster. For the first we have 0 and 1, we have 2. So like this, it's assigned to some clusters. So let's visualize that, the result. So we can easily create a scatter plot. Scatter, we need to plot the same x in the all the rows. Select the first column, that is 0 index, and the second column, all the rows. Second column index is 1. Okay, and then we give the color as the labels. So let's say we have three clusters, right? We color with the three colors, and plt dot show. Now if I run this two line, we will see the plot. And in the plot, so we have these three clusters. This is the light cluster is there, but you can't visualize that, that's why. So now if you see, so actually uh, this make blobs also given three clusters, but it's not shown here. So you can see here we have a cluster, it's a light color. So that's what the problem is. So this also, uh, in the second time if I run, you can see the new clusters here. We can set the random state for the make blobs function, because every time it will give you different clusters. You can see now if I run again, it will give you a different data, so like this. So you can see cluster number 1, cluster number 2, cluster number 3. Okay, I think the problem is color, I think. Okay, now also the same colors is coming. Okay, anyways, the KMeans clustering also is showing the same. So as you can see, this cluster here in the bottom, this is the created from make blobs function. And now see the KMeans cluster. So these are the same cluster, right? It's predicted the same cluster actually. Now in the second and the top we have this cluster, and this cluster is predicted in the KMeans is the light color, but I think it's not visualizing here. So you can see in the bottom we have a cluster, and the cluster is here in the black color. You can see that's also uh, clustered, I think perfectly. So this is how the K-means clusters is working. I think let's try with make circles. Make circles will create a circle type of data. So for that you need to give x and y. Call the function make circles. In the make circles same we'll give a number of samples. Number of samples will give 1500 the same data, and you need to give the will give the noise factor. Noise is 0.2, let's say, and we'll give the factor. Okay, and we'll command this line and we'll create the circle data. So you can see this is the circle data right here. So using the make circles function, it gives this circle data. But our K-means clustering algorithm is created the cluster as three clusters. But okay, we have given three clusters here. Let's make it two clusters. Let's see how it is. Yeah, it's dividing it with half, right? But we don't have to divide it like this. We have to divide it with the circle, but the K-means clustering is divided with half of the circle. So some algorithms, some clustering algorithms may not work with some shapes of data. So if you have this type of data, it's better you to use DBSCAN. We'll see that in the next. That's the DBSCAN algorithm. So because we have a noise here, right? So in the data you have a noise. Some algorithms like K-means or some algorithms cannot capture the noise. So to capture the noise, we have some other algorithms like DBSCAN. DBSCAN also predicts the noise, also separates the noise. Uh, so we'll see that. Uh, it's not responding. Yeah, start from current slate. And now the next algorithm will be DBSCAN. Uh, DBSCAN actually is a density based algorithm because it's clustered the algorithm where you see the most density, then it will create the cluster. So it's based on the density only. So the name is density based spatial clustering algorithm, spatial clustering of applications with noise. It's the expansion of DBSCAN. So it's a base algorithm for density based clustering. It can discover clusters of different shapes and sizes from a large amount of data which is containing noise and outliers. So we have noise and outliers also. It can capture the noise and outliers, the DBSCAN algorithm. And the DBSCAN algorithm uses two parameters. So you want to give two parameters, that is min PTS, that is minimum points. So minimum points in the cluster, minimum number of points, a threshold value, clustered together for a region to be considered dense. Actually, we see that I will show you. Epsilon, ps means epsilon, a distance measure that will be used to locate the points in the neighborhood of any data, any point. Okay, this is the parameters we will use, we need to assign in the model creation. And so three things you need to be considered. One is core. So in DBSCAN we have 3 points. One is core point and border point and noise point. So the core point is, this is a point that has at least m points. That's where m points is nothing but the minimum points here. So minimum points within distance n from itself. Okay, and border point, this is a point that has at least one core point at a distance n. And noise is the, this is a point that is neither a core nor a border, and it has less than m points within distance n from itself. So I will just explain you creating the plot. Okay, uh, so now in the DBSCAN what happening is, it takes the a circle, a radius of epsilon we have given. So using the epsilon it will create a circle. So first let me create some data points here, like this. Okay, so now in the uh, using the epsilon value, it tries to create a circle. For example, it creates here, let's take this data point and we'll create a circle, as take this as a center, and we'll create a uh, first let me use this data point or this data point. Okay, this data point will use, and it takes the center as this data point and will create a circle with the radius we have given. Okay, the radius we have given, it will create a circle, and actually the circle will move. Okay, no problem. So and then what happens is, we have given the minimum points parameter, right? Let's say I have given minimum points as 3. Okay, what happens is, I have created a circle, okay, with the radius epsilon, and in this circle, if we have number of points we have given, minimum points, minimum points is assigned to 3. So in this circle we have 3 points, right? So this is a core point. This is what the definition for core is. Core point, this is a point that has at least m points. So we have at least m points, right? We have minimum 3 points in the circle, okay, with the distance n. So now the circle is a, this will, this will become this will become a core point. Okay, and then we'll draw again. So let's take this point uh, as a centroid, and we'll draw a circle with the radius. And now again it will count the number of points in the circle. So we have minimum 3 points, so this point will become a core point. Again it will draw, let's draw a circle for this with the radius epsilon. Okay, so in this circle, see here, this is a point that has at least one core point, and at a distance n. So in here we have one core point, right? So this is a core point. Let's say we'll draw a circle again for this cluster, for this core point, and for this core point again we'll draw a circle, the radius epsilon. So take this circle, the top one. So in this circle we have a core point, one core point, right? In the radius of epsilon we have one core point. If we have one core point at least, then this point is a border point. Okay, so the definition for border is, this is a point that has at least one core point at a distance n. So we have a one core point here, right here. Okay. So and if you draw a circle for this data point, let's see, with the radius epsilon, you can see I'm drawing a circle, but this is a point that is neither a core nor a border, and it has less than m points. So we have less than m points, we have only one point here, not other, no other points here within distance n from itself. So this point is considered to be a noise, and this points as well. So we don't have any points on the radius. Okay, now this point may have a point, but it's also a noise. If we draw a circle for this, so this point has two points here, but it has one core point, so it's considered to be a border point. And these three are all noise, and this one is border actually. So it has one core point. If I draw a circle, so this is how the DBSCAN is working. Now if you do like that, it will create a cluster on where we have more density, right? So if you have more density, that means uh, all the data points go to the one cluster. This is how the DBSCAN is working, and it can also capture the noise as well. Okay, so this how, this is just an, I mean, animation how it's working. So you can see it's clustering where the density is here. So you can see the, in this circle we have a density, so it's trying to cluster that, and inside we have the density right here, so it will try to cluster that. So right here, these points are noise points, right? So you can see the epsilon is 1 and the minimum points is 4, said to be 4. So this is how the DBSCAN is working. Okay, now let's implement that. So DBSCAN can capture the density very easily. So if you have a circle type of data, it actually clusters perfectly. So but the K-means is not clustering, like it's clustering half of the circle, so we don't want to do that. So let's create a new file and we'll save it as DBSCAN. DBSCAN.py. Okay, so the same will import the libraries pandas, numpy, seaborn, the same thing here we'll do, and we'll import the function make blobs and make circles. Okay, and then now we're going to create a circles. First we do for circles make underscore circles, and here we'll give number of samples as 1500, and we'll give a noise as 0.6. Okay, more noise than the uh, k-means we have, and we'll give the factor as 0.4. Okay, now we'll create the data set. So we have created the data set. To visualize that, you can use these two lines. Okay, so this is what the data is. Oh, can decrease the factor. Or maybe I think I have more noise here. Okay, let's decrease. It's not looking like a circle, so we have more density there. So okay, now it's okay. How we created this plot? Okay, factor 0.5. Okay, I think we want to set the random state because it's changing every time. Okay, let's set the random state. We'll assign 15. Okay, now this like look like a circle. So now we want to create the model DBSCAN. First, you want to import the class from the SQL library. Inside you have a cluster module. Inside the cluster module, you will find the DBSCAN algorithm. DBSCAN, all are capitals, and we'll create an object for that cluster equal to, let's give DBSCAN, and here you need to give the parameter, right? What is epsilon, right? PS equals, I will give 0.3, 0.3 radius, and the default one is actually 0.5. I think we'll try with the default one, and then we'll see what happens. Okay, and now it will give you the labels, right? So the labels will give you, if you fit the data set, cluster.fit onto the dataset X, and it will give you the labels. So using that labels you can plot using these two lines, plt.scatter. Okay, so now let's run this program. uh, Float argument must be a string or number. What is here? Not DBSCAN. What? Okay, okay, I think the problem is here. DB, it's under a parameter that is called labels, labels underscore. That's why I, that's what the problem is here. Labels underscore. Yeah. Okay, now you can visualize the plot. Okay, what happening here is it's just creating a single cluster. So this happening, so previously when I take in the Tamil sessions also this happens, the same happens. It's just creating a single cluster, but in the circle we have two clusters, right? So it's just creating a single cluster. What happening here is, the problem is we need to standardize the scale of the data. That's what the problem is, main reason. So after standardizing the scale, and it's just creating a perfect clusters. I will show you that. First, we'll standardize the scale of the data. Okay, standard scalar, we want to fit the standard scalar in the X data. SD dot fit underscore transform. And now if you run, you will see the clusters. Yeah, now okay, Actually, I think we'll change the epsilon value. It is very large, I think 0.3. Okay, now these are okay. We have density right here. That's what it is. I think we'll keep the factor. Actually, in the dataset we don't have any gaps. That's why it's just creating a single cluster. So decrease the factor. My system also hanging. Okay. Uh, okay. Can you hear my voice or no? Because my system is okay. Yeah, yeah. Now got it. So we need to have a gap in the cluster. Then it will work. If you don't have,
Irfan, little bit louder, Irfan.
yeah, if you don't have gap in the cluster, it will create a single cluster like this because it's a density based algorithm. So maybe we can decrease the epsilon. We try with that. Yeah, now it's just clustering. Okay, so it's creating a different clusters. I think we'll assign the epsilon 3, but we'll assign minimum points also. Min PTS, right? Min PTS equal to we'll assign 3 minimum points. Oh, okay, minimum samples. Actually, we want a gap between the clusters, but we don't have any gaps. Uh, okay, I think we can increase the noise. Okay, increase the noise also is not working. Okay, what I will do is I will take the configurations what I did before in the previous session. So I have set factor 5, noise 0.6, and random state equal 20. So the configurations for the circle. Okay, now let's try. Okay, now it's creating a perfect you know so in the middle we have a cluster, so you can see the gap between the clusters. So that's what I am just wanted. And now in here it is just creating the same clusters. So now the DBSCAN also predict the cluster. I think I have given the large noise, I think. So previously I have given 0.6. That's what the problem is. 0.06 is better. Okay. So now you can see in the DBSCAN algorithm, you don't want to specify the number of clusters. It will automatically create the number of clusters based on the density. Okay, in the circle, if you see, you have the density, right? So that's why it's creating a cluster over the density. And this cluster also, it has light color. Okay. Okay, now what we'll do is we'll create the data set. We'll have the data set like iris data set. Let's take that, and let's try to uh, cluster the iris data set. Okay, so we'll try with KMeans and DBSCAN also. First, we'll try with KMeans. We'll read the data set, or you can load it from sklearn datasets. You can load sklearn.datasets. Here you have a function called load iris and create the data by calling the function, and it will return you the data, and you need to create the data frame pd dot data frame, and here you want to give the data that's inside the key data, and you want to give the column names, that is the parameter is columns, and the columns names are inside the feature underscore name, feature underscore names key. Okay, it will create a data frame, and this data frame is missing a column, that is a class, and the class is under the target key, target, and that's it. You have the data for iris. So now we'll visualize the iris data, it using the two features, first feature and second feature. The color is okay, I think df. Okay, we'll create the x and y. X equal to df dot ilog. The first four columns are x variables, so you can say for starting to 4, and we put dot values to create array, and for y it's a column of class. And now we can easily plot, and we'll give the number of clusters equal to 3. Okay, and now let's run this program. Let's see what happens. So this is the data set. You can see it's the data set. We have three class, black and is some color, and you have a light color also. So now the result, it is clustered by the k-means. Some points are not clustered correctly, but if you want to check the correct and incorrect predictions, you can use the confusion matrix. Sklearn dot matrix, import confusion matrix. Now mention confusion matrix, and I will give the y and the labels. Okay, y is the actual value and labels is the predicted values. Here I think okay, yeah, confusion matrix may not be correct, that's why, because some clusters are different here. Okay, cluster number 2 we have, this will be the cluster number 3, but in cluster number 3 we don't have more points, we have only 3 points. So these are all the incorrect predictions. If we try with a different cluster, it will be a different one. So it's a different one, right? So if you want to select the number of cluster, appropriate number of clusters, we have some methods. The first the method is using the elbow method. So elbow method using we can find an appropriate cluster, number of clusters. So the elbow method, what we need to do is we take the cluster number of values. Let's take it from the range 1 to 10. Okay, 1 to 10 we'll take. So from 1 to 10 we'll create the object of K-means clustering, and it's based on the inertia. So inertia is nothing but if you want to separate how the clusters are separated, that's the inertia value it will tell you. And using the inertia you can
Hello.
uh, yeah,
Irfan, in line number 27, the x variable is given twice. Is it supposed to be y? Second one?
yeah, I have plotted because in the x variable we have four features, but you can plot four features, right? So that's why I selected the two features, the first column and the second column. The index is 0 and 1,
Okay.
and the labels are different because you can see the colors, right, changing. That's the labels. Okay,
Yes. Okay.
okay. So we'll give the number of clusters is I, and then we'll create the object, and using this object we get the inertia and we'll store in the variable inertia. We'll create a list, okay, and we'll assign the inertia. First we'll need to fit that cluster into the data set x, and then we find the inertia and we'll append the inertia in the list. So you can find the inertia by cluster. Inside the cluster if you put dot, and you can have the inertia value right here. I think that's inertia underscore, maybe, yeah. And then after getting the inertias you can plot with the simply plt dot plot, okay. And now give the inertia list, and we'll show the plot, that's it. Yeah, now you can see this is the number of clusters. You can mark with that, marker equal to O to mark the points. So like this we have the points, right? So the appropriate clusters, number of cluster will be 2 or 3 maybe, I think. Yeah, so inertia is getting lesser, right? You will select the number of clusters where the inertia is changing. So here it's changing 2, and you can select or 3 also. Okay, this was the method of elbow method. Using the inertia we'll find the number of clusters. Okay, in the case of DBSCAN you don't have to select the number of cases, sorry, select the number of clusters, but you can tune the parameters of epsilon value and the minimum samples. Okay, minimum samples also you can tune. Okay, so this what the algorithms KMeans and DBSCAN. So we'll end this session right here. So if you have any doubts you can ask. I think sometimes if I open many applications my system is hanging. Now it stopped. Participant 6 is not responding.